Hi everyone, today we'll be looking at the Pure Mathematics 1 paper of June 2021. In question 1, we're being given the curve C with this equation here, and we need to find the y dx, giving our answer in simplest form. So I will actually start off by writing out y as x squared over 3 plus 4x to the minus a half plus 8 over 3 x to the minus 1 minus 5. I need to have x to some power for each term so I can get the power down and deduct 1 from the power when I differentiate. So dy dx will be 2x over 3 plus 4 times minus a half x to the minus 3 over 2 plus 8 over 3 times minus 1 x to the minus 2. Then negative 5 goes away, and the only thing left to do is simplify the terms. So it's going to be 2x over 3 minus 2x to the minus 3 over 2 minus 8 over 3x to the minus 2. This was for 4 marks. And then part B, we're being given that point P with coordinates 4, 3 lies on C. And we need to find the equation of the normal to C at the point P, giving our answer in this particular form. So I will start by evaluating dy dx at x is 4 in order to recover the gradient of the tangent at x is 4. So it will be 2 times 4 over 3 minus 2 times 4 to the minus 3 over 2 minus 8 over 3 times 4 to the negative 2. This gives an answer of 9 over 4. Remember, we're trying to find the gradient of the normal, so the normal is perpendicular to the tangent, and therefore I flip and I change sign. The gradient of the normal is minus 4 over 9, and then y minus y1 is mx minus x1, y minus 3 is minus 4 over 9 brackets x minus 4. I will cross multiply to get 9y minus 27. I will expand the right hand side into minus 4x plus 16, and then collect everything on the left. 9y plus 4x minus 43 is 0. In question 2, we are being given f of x here in terms of a constant, a positive constant alpha. And we are also told that f of minus 1 is 32. And we need to show that the only possible value for alpha is 3. So what we could do is actually substitute x with minus 1. So f of minus 1 is 32, means that a times minus 1 cubed plus 6a plus 8 times minus 1 squared minus a squared times minus 1 is 32. So minus a plus 6a plus 8 plus a squared is 32. I will collect everything on the left hand side. It's a quadratic. A squared plus 5a minus 24 is 0, which factors into a plus 8, a minus 3. So either a plus 8 is 0 or a minus 3 is 0, which means that a is negative 8 or a is 3. We need to be careful at this point. We've been told that a was positive, there it is, and therefore I need to explicitly reject the negative. So I say reject since a is positive, and I'm left only with a is equal to 3. And then the II part, using a is 3, I need to solve the equation f of x is 0. So now that we know the value of a, I will simply say that f of x is 3x cubed plus 6 times 3 plus 8 in brackets x squared minus 3 squared times x. So this is 3x cubed plus 26x squared minus 9x. I will factor out the x to give me x brackets 3x squared plus 26x minus 9, which further factorizes into x 3x minus 1 x plus 9. So if f of x is 0, this simply means that either x is 0 or 3x minus 1 is 0 or x plus 9 is 0. So it could be x is 0 or 3x is 1, which means that x is a third, or x is negative 9. So it was a cubic giving 3 distinct solutions. Then in part B, we're given 2 equations that have some resemblance to f of x, and we need to solve them both being equal to 0. Now, if we look at the first one here, we can see that the x has been replaced by y to the 1 over 3. So this is what we are given in BI. We have 3y plus 26y to the 2 over 3 minus 9y to the 1 over 3 is 0. Remember that we recovered f of x to be 3x cubed plus 26x squared minus 9x. So when we solve this being equal to 0, it's exactly the same with this one here, with x being y to the 1 over 3. So if we have x is y to the 1 over 3, it means that the 3 solutions, x is 0 or a third or minus 9, are now y to the third is 0 or y to the third is a third or y to the third is negative 9. Now the way to remove the power of a third is to raise the other side to the power of 3. So we get y is 0 cubed, so y is 0, or y is a third cubed, which means that y is 1 over 27, or y is minus 9 to the power of 3, which is minus 729. So 3 possible solutions. And then in II, we've got this here. So I'm just gonna write it and compare with f of x. We have 3 times 9 to the 3z plus 26 times 9 to the 2z minus 9 times 9 to the z is 0. So it's obviously the case here that x is 9 to the z. Now this means that 9 to the z is 0 or 9 to the z is a third or 9 to the z is negative 9. Well, we need to bear in mind here that if I raise 9 to any power, I cannot get a negative answer. So it must be the case that I only want x greater than 0, because 9 to the z cannot be 0 or negative, which immediately means that 9 to the z being 0 is not valid, and 9 to the z being negative 9 is also not valid. So the attention is on 9 to the z being a third. I will write 9 as 3 squared raised to the power of z, and I will write a third as 3 to the minus 1, which means 3 to the 2z is 3 to the minus 1. And since the bases are the same, I can now equate the indices. I get 2z is negative 1, which means that z is minus a half. In question 3, we're being given a triangle ABC with the given information here, the sides PQ and 2 root 2, and the angle here 60. And we are being asked to show that P squared plus Q squared minus PQ is 8. It actually makes sense here to use the cosine rule. So I've got the lengths of the 3 sides, and I've got one angle. So I start from the side which is opposite the angle of interest. So 2 root 2 all squared is equal to P squared plus Q squared minus 2 times P times Q cos of 60. Now 2 root 2 all squared is 8, so it's P squared plus Q squared minus 2PQ, and cos of 60 is a half. which means that 8 is p squared plus q squared minus pq. And this is exactly what I had to show, so this is as required for 2 marks. Given that side AC is 2 meters, longer than side AB, we need to use algebra to find the value of P and the value of Q. So I'm actually being told that Q is P plus 2. So I will start with this. I'm essentially looking at simultaneous equation. So 8 is P squared plus P plus 2 squared, replacing Q with P plus 2, minus P times P plus 2. I will expand here to get 8 is P squared plus 4P plus 4 minus P squared minus 2P. And now collecting everything on the right hand side, I get 0 is P squared plus 2P minus 4. And therefore, I can use the quadratic formula here to find the value of P. So P is minus B plus minus B squared minus 4AC square root of this, all of it over 2 times 1. So this is P is minus 1 plus minus root 5. Obviously, P being a length, it cannot be minus 1 minus root 5. So I have to go with P is minus 1 plus root 5. If you look at the question once more, you would see that they were asking for the exact value of P. So they expected a single value given in exact form. And then for Q, I'm going to use the fact that Q is P plus 2. So it's minus 1 plus root 5 plus 2. So it's 1 plus root 5. And then part C, using the answers here, calculate the exact area of the flower bed. Well, we know a formula that says that the area is given by a half AB sine C. So it's going to be a half times P times Q times sine of 60. So P, we found this to be minus 1 plus root 5. Q, we found it to be 1 plus root 5. Sine 60 is root 3 over 2. I will be showing all the working out here. So it's a half. In brackets, the expansion is minus 1 minus root 5 plus root 5 plus 5 times root 3 over 2. The root 5s go away. So I'm left with a half times 4, the minus 1 plus 5, times root 3 over 2. And 2 times 2 is 4. So all of this is root 3 square meters. In question 4, we need to find this integral here, giving our answer in its simplest form. So I will actually start by expanding the numerator and then simplifying with the denominator before I actually move on with integrating. So if we expand the numerator, we get 3x to the 3 over 2 minus 15x to the half plus 2x minus 10, and all of it over 4x to the half dx. I now need to express this in a term by term case. So it's going to be the integral of 3x to the 3 over 2 over 4x to the half minus 15x to the half over 4x to the half plus 2x over 4x to the half minus 10 over 4x to the half dx, which means I'm looking at 3 over 4x minus 15 over 4 plus a half x to the half minus 5 over 2 x to the minus a half dx. And we are now ready to integrate. We increase the power by 1, dividing by the new power, so it's 3 over 4x squared over 2 minus 15 over 4 times x plus a half x to the 3 over 2 over 3 over 2 minus 5 over 2 x to the half over a half. Don't forget the plus c, this is indefinite integration. And the only thing left to do here is simplify terms. So it's 3x squared over 8 minus 15x over 4 plus a third x to the 3 over 2 because the 2 with the 2 cancel out, minus 5x to the half with the 2 and the 2 cancelling out, plus c. In question 5, we've got the graph of the share value of two companies, A and B, being monitored over a 15-year period. And this is an expression for the share value of company A in millions of pounds, and similarly for company B. And we need to find the difference between the share of A and the share of B at the point the monitoring began. So I will actually start by evaluating both of these when t is 0. So when t is 0, we get that PA is 53 minus 0.4 brackets 0 minus 8 squared, which is 27.4. PB is minus 1.6 times 0 plus 44.2, which is just 44.2, and therefore the difference is 44.2 minus 27.4, which is 16.8, and remember it's a million pounds here. If you do not include the millions, then you will be penalized. We are then being asked to state the maximum share value of company A during the 15-year period. Now the prompt of stating implies that there is no much of a calculation to be carried out. We have been given P of A in this form. It will hit a maximum when this is 0. So it will hit a maximum of 53. Because we are at 53, take away something square, which is always positive. So the maximum we can be at is 53. So 53 million pounds is the answer to part B. Then for C, we need to use algebra to find the times during which this 15-year period the share of A will be greater than the share of B. So in other words, we have been asked to solve P of A greater than P of B in this 15-year period, so between 0 and 15. So I will replace P of A with the expression 53 minus 0.4 brackets t minus 8 squared greater than minus 1.6 t plus 44.2. Let's expand the left hand side. Is 53 minus 0.4 t squared minus 16t plus 64 close brackets greater than minus 1.6 t plus 44.2. A further expansion on the left hand side is giving me 53 minus 0.4 t squared plus 6.4 t plus minus 25.6 greater than minus 1.6 t plus 44.2. I will collect everything on the right hand side because I want the leading coefficient, the coefficient of t squared, to be positive. And this will give me 0 greater than 0.4 t squared minus 8t plus 16.8. Now this is a quadratic inequality. I will use the quadratic formula to extract the critical values. So minus b plus minus b squared minus 4ac square root of that over 2a, which is 2 times 0.4. We get that t is 10 plus minus root of 58. I can actually draw my smiley parabola here with the critical values at 10 minus root 58 and 10 plus root 58. The y values go plus, minus, plus. We want to be less than 0 here, so we want the negative part. So from here, we can see that t has to be between 10 minus root 58 and 10 plus root 58. However, in addition, we want t to be between 0 and 15, as we already said. So I need to restrict the values into all values of t that are between 10 minus root 58 and 15. If you calculate 10 plus root 58, you will see that you get a value which is greater than 15. So you know that this model only holds true for up to values of t up to 15, so you need to impose this extra restriction here. 10 plus root 58 is actually 17.6. That's why we stop at 15. And then D, explain why the model for company A should not be used to predict the share value when t is 20. Well, what we could do is actually say that when t is 20, if I substitute into P of A, I get 53 minus 0.4 brackets 20 minus 8 squared, which is minus 4.6, which is less than 0, so not valid. And hence the model should not be used for t is 20. Alternatively, someone could say that we have been told that it's valid for the first 15 years, so I wouldn't be using it for the 20th year to predict the profits. In question 6, we're being given this curve C with equation y is f of x. We have been told that it passes through the point 8, 2. We have an expression for the derivative function, and we need to find the equation of the tangent to C at P, giving our answer in the form y is mx plus c. So I will actually start by finding f dash of 8. This will be the gradient of the tangent at x is 8. So 32 over 3 times 8 squared plus 3 minus 2 times the third root of 8. This turns out to be minus 5 over 6. So we've got the point, we've got the gradient. Y minus y1 is m brackets x minus x1. So y minus 2 is minus 5 over 6 x minus 8. I will now expand this. I get y minus 2 is minus 5x over 6 plus 20 over 3. So if I collect everything on the right hand side, y is minus 5x over 6 plus 26 over 3, therefore matching the form in which I had to give my answer to. Part B, we need to find in its simplest form f of x. Now we will start by integrating, because we've got the derivative function. To go back, we need to integrate. So f of x is the integral of f dash of x dx, which is the integral of 32 over 3x squared plus 3 minus 2 times the third root of x dx. This is written as 32 over 3x to the minus 2 plus 3 minus 2x to the third. This will allow me to perform the process of increasing the power by 1, dividing by the new power. So it will give me 32 over 3x to the minus 1 over minus 1 plus 3x minus 2x to the 4 over 3 over 4 over 3 plus c. So I will simplify this first of all. It's minus 32 over 3 x to the minus 1 plus 3x minus 3 over 2 x to the 4 over 3 plus c. We know that we pass through the point 8, 2. this means that f of 8 is 2, and therefore 2 is minus 32 over 3, 8 to the minus 1, plus 3 times 8, minus 3 over 2 times 8 to the 4 over 3, plus c. So 2 is minus 4 over 3 plus c, which gives me a value for c, which is 10 over 3. And the only thing left to do to claim full marks is write f of x is minus 32 over 3x to the minus 1 plus 3x minus 3 over 2x to the 4 over 3 plus 10 over 3. In question 7, we are being given the line L1 with equation 4y plus 3x equals 48. I might as well annotate the diagram here with a line 4y plus 3x is 48. Now the line L1 is cutting the y-axis at C as shown here, and we need to state the y-coordinate of C. Well, obviously a cut on the y-axis means that x is 0, so at the point C, x is 0, which means that 4y is 48, and therefore the y-coordinate of this point is 12. And again, I'll go back to my diagram and put the coordinate here. It's really crucial that you have all the information in one place, you see exactly what's happening. And then it's the point D with coordinates 8, 6 lying on L1. So this is D here, the point of intersection between L1 and L2. And we know that this line L2 is passing through the point D and it's perpendicular. So it creates a right angle here. And we need to show that the y-coordinate of E is minus 14 over 3. So I will start by using the fact that the two lines are perpendicular, which means that if I knew the gradient of L1, I could derive the gradient of L2. So let's start with L1. The equation for L1 is 4y plus 3x is 48. I will make y the subject here because this will allow me to simply see the gradient of L1. So y is minus 3 over 4x plus 12. So the gradient of L1 is minus 3 over 4. And therefore the gradient of L2 can be found by flipping and changing the sign. It's 4 over 3. And then for L2, we know that we pass through the point 8, 6. So y minus y1 is mx minus x1. So y minus 6 is 4 over 3 x minus 8. We know that the point E is a cut on the y-axis, so at E x is 0, which means that y minus 6 is 4 over 3 times 0 minus 8. So y minus 6 is minus 32 over 3, which means that y is minus 32 over 3 plus 6, which gives me the minus 14 over 3 as required. It was a show that question, so I had to show everything very carefully to claim the full marks. C, we have a sector BCE. The angle is 1.8 radians. We need to find the length of the arc BE, the length of this arc here, BE. So we know that the formula for the length of an arc is r theta when theta is in radians, and the radius is this part here, which is the difference between the y values, the y coordinates of C and E. So that's where we start. So the radius will simply be 12 plus 14 over 3, which is 50 over 3. The length of the arc is r theta, and theta must be in radians, which in this case it is given in radians. So it's 50 over 3 times 1.8, which gives me an answer of 30 units. And then part D, we need to calculate the exact area shown shaded here. We can easily analyze this into a sector. We know the formula for the area of a sector. It's a half r squared theta, when theta is in radians. And then we need the area of this triangle. Now for this triangle, I could actually consider this to be the height and CE is the base. Now the height here is simply the x coordinate of D, which is 8. So I pretty much have all the information I need. So in D, I will say the area is the area of the sector plus the area of the triangle. So the area of the sector is a half r squared theta, and the area of the triangle will be base 50/3 times the height of 8/2, which gives an answer of 950/3 units squared. We have to be careful here. We have been told to find the exact area, so we shouldn't be giving answers in decimal form. Just keep it exact as a fraction to claim the full marks. In question 8, we need to start off by writing 3x squared plus 6x plus 9 in this form. So we're pretty much being asked to complete the square here. So we can start by saying 3x squared plus 6x plus 9 is equal to 3 brackets x squared plus 2x close brackets plus 9. So I will complete the square onto x squared plus 2x. It's x plus 1 all squared minus 1 squared. So it is 3x plus 1 squared minus 1 plus 9. So this is 3 brackets x plus 1 squared minus 3 plus 9, which leads to 3 brackets x plus 1 squared plus 6. So we can simply state that A is 3, B is 1, and C is 6. There's also an alternative approach. I could use the fact that I've been given the form in which I need to give my answer. So I can say 3x squared plus 6x plus 9 is equal to A brackets x plus b all squared plus c. I expand the right hand side into x squared plus 2bx plus b squared close brackets plus c. And the further expansion will give me ax squared plus 2abx plus ab squared plus c. And then I equate coefficients. The x squared term has a coefficient of 3 on the left and a coefficient of a on the right. So it must be the case that 3 is equal to a. Now I look at the x term, it's 6, and now it's 2ab. So we have that 6 is equal to 2 times AB, but we have found A to be 3. So we get that 6 is 6B, and therefore B turns out to be 1. And finally, 9 is AB squared plus C. So we have that 9 is AB squared plus C. I replace A with 3, B with 1. And I get that 9 is 3 plus C, which gives me 6 is equal to C. An equally acceptable method, maybe a bit longer, but you're still gonna score the 3 marks given here. Now in B, the point P is the minimum point. Deduce the coordinates of P. Again, the instruction, the prompt to deduce, means it's something that follows on from the work you've just completed. The fact that you have put the expression in this form here, means you can easily see that the minimum point is when this is 0. So the x value that will make the bracket 0, which is obviously gonna be minus 1. And when x is minus 1, the y value turns out to be 6. So this is minus 1,6. And then we've got a different curve C2. It's a cubic curve ax cubed plus bx squared plus cx plus d. A, B, C, D are constants, and what do we know about C2? We know that it passes through P, and it's intersecting at -4, -2, and 3. And we need to find for 5 marks the values of A, B, C, and D. So I will start by identifying that for me to have cuts at x is -4, x is -2, and x is 3, it means we have factors of x plus 4, x plus 2, and x minus 3. Now, these are 3 factors. We are looking for a cubic, so it must be the case that y is the product of these 3 cubics, and the only thing that could change is whether the coefficient here is 1 or something else. So I'm gonna put a k here, and I'm gonna use the fact that we pass through -1, 6 to identify the value of k. So the curve passes through -1, 6, which means that when x is -1, y is 6. So this means that 6 is k times -1 plus 4, -1 plus 2, -1 minus 3. So 6 is k times 3 times 1 times -4. So 6 is -12k. So -1/2 is k. Now, where do we stand? We have just established that y is -1/2, x plus 4, x plus 2, x minus 3, but we haven't really finished. We need to expand to identify the coefficients a, b, c, and d. So it's -1/2. X plus 4 times x plus 2 is x squared plus 2x plus 4x plus 8 times x minus 3. So it's -1/2 x squared plus 6x plus 8 times x minus 3. So we will expand once more to get -1/2 x cubed minus 3x squared plus 6x squared minus 18x plus 8x minus 24, which is -1/2 x cubed plus 3x squared minus 10x minus 24, which gives me -1/2 x cubed minus 3 over 2x squared plus 5x plus 12, which means that a is -1/2, b is -3 over 2, c is 5, and d is 12. So that was one way of solving this. It all depended on you realizing that for me to have these cuts on the x-axis, I needed to have these 3 factors, and then working with this idea of the k. Now, was there another way? Of course, there's another way. Alternatively, we could have used the original expression given. We have that y is ax cubed plus bx squared plus cx plus d. And I'm gonna use the fact that we pass through -4, 0, which leads to 0 is a times -4 cubed plus b times -4 squared plus c times -4 plus d. So this gives me 0 is -64a plus 16b minus 4c plus d, and I will label this equation 1. What else do we know? We know that we pass through -2, 0. So 0 is a times -2 cubed plus b times -2 squared plus c times -2 plus d, which means 0 is -8a plus 4b minus 2c plus d, and I will label this equation 2. We also know that we pass through 3, 0. So 0 is a times 3 cubed plus b times 3 squared plus c times 3 plus D, and this simplifies to 0 is 27A plus 9B plus 3C plus D, and we label this equation 3. And finally, the fact that we pass through minus 1, 6 means that 6 is A times minus 1 cubed plus B times minus 1 squared plus C times minus 1 plus D. So 6 is minus A plus B minus C plus D, and I will label this equation 4. Now, if I deduct 1 from 2, so if I do 2 minus 1, I see that I get 0 is 56A minus 12B plus 2C. What I'm dealing here is a system of 4 simultaneous equations in 4 unknowns. So I get that 0 is 28A minus 6B plus C, and I will call this equation 5. I will also do equation 4 minus equation 3. So 4 minus 3 is giving me that 6 is minus 28A minus 8B minus 4C. So if I divide everything by 4, I get 1.5 is minus 7A minus 2B minus C, and I will call this equation 6. I will also do 3 minus 2. So if I do 3 minus 2, what I get is 0 is 35A plus 5B plus 5C. So 0 is 7A plus B plus C, and I will call this equation 7. Now, if I add 6 and 7 together, I see that I eliminate everything and I can get B, because I get 1.5 is negative B. So minus 1.5 is the value of B. Now, we've got the value of B here. So I can go into equation 6 and I can say that 1.5 is minus 7A minus 2 times minus 1.5 minus C. So 1.5 is minus 7A plus 3 minus C, which means that C turns out to be 1.5 minus 7A. So we've got now an expression for C in terms of A. And we can also go into equation 5 now. This equation 5, I will replace the B with the minus 1.5. So 0 is 28A minus 6 times minus 1.5 plus C. So 0 is 28A plus 9 plus C, which means that minus 28A minus 9 is C. I've got two equations for C in terms of A. I will set them equal. So minus 28A minus 9 is 1.5 minus 7A, which means that I get minus 10.5 is 21A, and therefore minus a half is the value of A. So where do we stand up to now? We have found the value of B, we have found the value of A, and we need to go back. I'll go back here to find the value of C. So C is 1.5 minus 7 times minus a half. So this is 5. So we've got the value of C as well. And the only thing missing is to go into any one of these equations. Here I could go to equation 4 here and substitute. I get 6 is, I'll write it in red so it's clear. 6 is minus A plus B, which was minus 1.5, minus C, which was 5, plus D. We get 6 is minus 6 plus D, and therefore we get D to be 12. We recovered the same values for A, B, C, D, but certainly through a lot more working, taking more time, increasing our chances for a mistake.
In question 9, we need to state an equation for L. L is the asymptote here for tan x. So we know that tan x has asymptotes at pi over 2 and then every pi radians afterwards. So this is x is pi over 2 and this is x is 3 pi over 2. So the answer to part A is x is 3 pi over 2. And then part B, we need to sketch the curve with equation y is 1 over x plus 1. We need to state the equation of the horizontal asymptote of this curve. So if we start with y is 1 over x plus 1, the first thing we notice is that we've got a vertical asymptote at x is 0, because if we put x to be 0, then we've got 1 over 0, which is undefined, so x is 0 is an asymptote. For the horizontal asymptote, what we can do is we allow x to grow really large. So we consider the behavior as x tends to infinity. So as x tends to infinity, then this is 1 over infinity, which goes to 0, and therefore y is equal to 1. Y goes to 1, and therefore the asymptote is y is 1. And I could also find the cut on the x-axis, which means that y is 0, and therefore we've got 1 over x plus 1 is 0, 1 over x is negative 1, so x is negative 1. So I've got enough information to actually sketch 1 over x plus 1 here. This is the asymptote at y is equal to 1. And we are cutting the x-axis at negative 1, we said, so it's probably something like this. And over here like that. And this is the negative 1 here. So this is what we have. Now, in II, it says, hence, giving a reason, state the number of solutions for tan x is 1 over x plus 1. So we are looking at the points of intersection. We've got 1, 2, 3, 4, 5, and therefore we can say that we've got 5 points of intersection, hence 5 solutions. And then part C, we need to state the number of solutions between 0 and 40 pi, and then between minus 10 pi and 5 over 2 pi. Now, we need to bear in mind that this interval here ends at 2 pi, and this is minus 2 pi. And therefore, we see that between 0 and 2 pi, we've got 2 solutions. And every 2 pi afterwards, we'll be having another 2 solutions. So from 0 to 40 pi, we have 20 intervals of 2 pi, each contributing 2 solutions. So 20 times 2, that will give me 40 solutions. And then for II, I'm between negative 10 pi and 5 pi over 2. Well, we have to be careful here. So in the negatives, so from 0 up to minus 10 pi, we have 5 intervals of length 2 pi. Each one will be having 2 solutions, apart from the first one, which is having 3. All others will be having just 2 solutions. But the first one, the first interval from 0 to negative 2 pi, is having 3 solutions. So from negative 10 pi to 0, we've got 5 intervals, each with 2 solutions, plus that extra solution we've got over here. And then from 0 to 5 pi over 2, where from 0 to 2 pi, it's these 2 solutions here. So plus another 2. And then from 2 pi to 5 pi over 2, well, we will be having another solution, because essentially it's gonna be this part here repeating over here. It's gonna be like this. So I'll be having another solution here between 2 pi and 5 pi over 2. So plus another 1. So it's 10, 11, 13. It's gonna be 14 solutions all together.